Okay, so welcome everybody. I'm going to talk today about using Ceylon with, which is a programming language, with some Java EE technologies, JPA, CDI, JAX-RS, and some other technologies which are used within which are available within Java EE-like platforms. The Ceylon project is a project we've been working on for a number of years at Red Hat. But it's still a relatively new programming language, which features a powerful and we think very elegant type system. It features a built-in module system built into the language and the tooling. It has support for multiple virtual machine platforms. You could run Ceylon on a Java virtual machine, including on Android, which is not quite exactly the same thing as a Java virtual machine. You can run it on JavaScript virtual machines. You can run it on the Dart VM, so it compiles to all these different VM targets. It supports interoperation with native code written directly for any of those platforms. So it'll interoperate with Java, with JavaScript, and with the Dart language. One of the things that, being a language with static typing, one of the things that we emphasize very strongly is the importance, is the tooling that enables. So, Ceylon is a language, or as any statically typed language is, it's a language designed to enable, powerful tooling. In this case, we have, a great command line tool set for compiling Ceylon code, for managing modules in module repositories, for doing lots of things which we'll touch on a little bit later. And we have really great, really full-featured plugins for Eclipse and IntelliJ and Android Studio to do all those kind of things that IDEs help you do. So when I was here last time, which was a couple of years ago, I'm not sure if anybody was here for that talk, but last time I was here I talked a lot about the type system of Ceylon, which is at least to me and probably for many people, kind of the most exciting topic there is, to talk about with respect to the language. But obviously this time around, I needed to find something different to talk about. So this time I'm going to talk about, taking from a more practical perspective, I'm going to talk about interoperation with, several Java frameworks. And what I'm going to show is a small demo app I wrote that's based in the Wildfly Swarm environment. What I like about this is that, it's a great test case for the interoperation of Ceylon with Java and with Java frameworks, okay? This really, this has some, things which kind of push the limits, our interop story. This is not the only test case that we've targeted, other environments which we've done even more work include like Eclipse and OSGI. We've written Eclipse plugin, a major Eclipse plugin in partially in Ceylon, as a set of OSGI modules. We've written an entire IDE plugin for IntelliJ. Another platform that we've targeted that I talked about at DevOps US recently is the Android environment, and we've also done a lot of testing of some other smaller libraries and frameworks. But this is the one I'm going to focus on today, just because it's something I haven't talked about before. And particularly, what I'm going to show off here as well at the same time is Wildfly Swarm. So Wildfly is, what is the, I'm not sure if you're aware, is what JBoss application server was renamed some time ago. The open source version of JBoss application server was renamed. Wildfly Swarm lets you package, that's Wildfly. Wildfly Swarm is, you know, an interesting technology based off of Wildfly that lets you package your Java EE app and the server itself as a fat jar, right? So it offers the Java EE APIs without a container as such. It'll just kind of bundle the bits of Wildfly that you need together with your application and all the dependencies that your application has into a single jar, and then you can run it with Java minus jar. It also provides some infrastructure for running this stuff as a microservice with service discovery, failover, tooling for integrating with Red Hat cloud technology, stuff like that. I'm not going to talk anything about that because, frankly, it's not my area. So what would we use Ceylon with Swarm? Well, basically, you know, Ceylon is a really nice language. It makes it easy to write very robust code. It makes it very easy to write very general code as well. So some things you'll get with Ceylon that you won't get with other languages, true null safety. Okay, null. You know, there's no more null pointer exceptions in your code because null is modeled correctly within the type system, and just in general, a lot more errors detected at compile time rather than at runtime, and that saves a lot of time. You get union intersection types. Again, I'm not going to talk about it here, but that is something which, if you start writing code in Ceylon, you'll find yourself using all the time. It'll change the way you can write. You write code. It'll change what you can do with static typing. It's amazingly useful. You get tuple types. You get type inference and flow sensitive typing, which cuts down on a lot of the syntactic overhead of using a language with static typing. You get much better support for the use of immutability. Ceylon comes with things like immutable tuples and built into the language itself. You get a streamlined syntax for defining kind of model or data classes, the kind of classes that you would persist to a database, or that you would, serialize or externalize to JSON or XML. And that's going to be rather important in this little demo app that we're going to look at, because that's one of the things we're going to touch on. And you get a type-safe meta model. We'll see a bit later, I'm going to explain what that is, and we'll see a little bit later how that turns out to be useful here. So the demo app I'm going to show is, the point of it is that we want to make the most of Java EE APIs, including especially JPA, CDI, and JAX-RS. We're going to use a couple of other things like transactional, but we want to be able to write the code so that we're writing code which looks like totally an idiomatic, natural Ceylon, and at the same time is also completely natural Java EE code. Now you might say, well, Java EE's suddenly go green. So you might say, well, I'm not really interested in Java EE. What do I need? Do I really need all this if I want to use, Ceylon to write my microservice? No, you don't need to use this platform, this environment, unless you want to. There's plenty of other options you have. You could use, Ceylon.dbc, which is a simple kind of wrap around JDBC, or you could use standalone JPA for persistence. You could use Ceylon.json as a module for producing and parsing JSON. You could use Ceylon HTTP server. You could use Vertex. You could use oodles of other Java web frameworks and HTTP servers if you prefer. If you want dependency injection, if you especially want dependency injection, you could use Juice or Weld. Or if you prefer, you could use Spring. Ceylon will work with all these technologies. The reason I'm, focusing here on Swarm is not to say that, it's not even really to say, the point is not to recommend it, especially, whether it fits, makes sense to you guys, depends upon your needs. It's just, as an example environment to demonstrate, some of the issues that arise and how we've solved them. All right. So the issues that arise. The challenge, the first challenge we ran into is that, obviously JPA, CDI, JAX-RS, these Java EE technologies that we're most interested in here are annotation-driven frameworks that work via Java reflection. Okay, now that means that they get in and stick their fingers in and get access to the internal, implementation details, internal fields of the Java classes you write. Now, in earlier versions of Ceylon, the mapping to Java, by which I mean the way we compile Ceylon code into Java classes, right, at the bytecode level, all right, but that's also that mapping is also what a native Java code will see the Ceylon classes as, right, okay. Wasn't really especially optimized for these kind of annotation-driven Java frameworks. We kind of took a little bit the point of view that, well, what I care about is what this class file will look like to an external Java client that's calling it via its public API, right? And precisely what Ceylon generates as the private implementation details shouldn't be interesting, right? We should just do what's the most optimal thing for performance, blah, blah, yada, yada, yada. Okay. Unfortunately, then, when we came to look at things like JPA and JAX-RS, we found that there was a couple of things which didn't quite work out, right? You needed, for example, to define JPA converters or JAX-RS adapters to kind of map some of the primitive type string, float double. One of the things is that the Ceylon compiler generates a lot of final fields and methods, okay? And that wasn't too great for things like CDI, which wanted to have proxies, right? So you would have to kind of explicitly go and annotate the methods of your class's default, so that they could be, proxied by CDI. Or I think the same thing affected JAX-RS, right? There were some problems with generated value in JPA. I'll show you in a second, I guess. And in the end, you can make it all work, but I mean, it works fine. But it doesn't quite all come together for a really nice, clean, pretty demo app, right? So. The second part of the challenge is that some of the JPA APIs aren't optimized for usage from the Ceylon language. In particular, the set parameter methods on the query object in JPA accept object. And so, the conversion of Java primitive wrapper types isn't automatic. Again, it's something that was solvable by defining those JPA converter objects, and that's the approach that the JPA offers you to solve this problem, right? But, that's not, so nice in a demo app. Operations of the JPA entity manager all accept null, because Java itself doesn't have type safe null, and so all the APIs of Java don't define whether they accept null or not. And again, these issues really aren't showstopper, and you can use the JPA's API directly from Ceylon without any real difficulty at all. But, it's just not quite as comfortable as, we're looking for perfection here, not, oh yeah, you can make it work, all right? We're looking for, it's beautiful, not it's okay. So, the solution to the first problem, the first challenge, was to add, and this is something we added about, I don't know, maybe almost a year ago, a special mode to the Ceylon compiler called, actually minus EE, minus EE, that adjusts the mapping to Java so that annotation-driven Java frameworks will work more smoothly with Ceylon objects. You need to use direct field access in JPA and JAX-RS to get the best of it. And the nice thing about it is that EE mode is that enabling this EE mode doesn't affect the external public API of these Java classes, right? There's no binary compatibility issue with turning that mode on and off. All it affects is the private fields of the class, okay? So the only thing, it doesn't even affect use of these Java classes through Ceylon's use of the Ceylon classes through Ceylon's meta model, through Ceylon's reflection API. The only thing it really affects is access to these classes' private members via Java reflection. Okay. So you just turn that on. I'll show you how easy that is in our application here. It's just a setting for the Ceylon compiler. Minus my is EE if you invoke it from the command line, or E equals true in the IDE. You can see this is a file where settings to pass to the Ceylon compiler are stored. All of these are basically the defaults, and we could delete them, but the IDE generates those just so that you can easily change them. This is the one which I had to set explicitly, right? Yep. Okay, the solution to the second problem of the JPA APIs is that we wrote, again, I'm not sure, 6 months ago, something like that, I wrote a module called Ceylon.interrupt.persistence that forms now part of the Ceylon SDK. That's a wrapper, not even really a wrapper. It doesn't totally try to totally abstract JPA. Just a little wrapper for a couple of the important APIs in JPA that offers much better type safety for a Ceylon client. Okay, in particular, it has a a criteria query API that we'll see a bit later. That's a big improvement over what JPA offers. Now that criteria API, I'm still working on it. I only just finished it, and it's only available in Git or in the next release of Ceylon. Okay, this SDK module also solves the set parameter discomfort I mentioned. So we can see. Oops, no, I didn't want to do that. So we can see how I've integrated into my application. Okay, let's go to the, oops. So this is my module descriptor for my Ceylon module, which is my my little demo. You can see that I've declared a module named jaxrs.example. It's a native JVM module. It's only going to run on the Java virtual machine. It imports the Java EE APIs as a single module, and it also depends upon this module I mentioned called Ceylon interrupt.persistence. Okay, and if you look at the docs for that, this explains all that does. It provides a Ceylonic entity manager for use with the Java persistence API. Okay. Right. So you can see, this is what it looks like in Ceylon when you use a dependent module. You declare that dependency there in your module descriptor. You declare the version of the module you want to use. You can declare dependencies to Maven modules. If you're writing in JavaScript, you can declare dependencies to Node modules. In this case, these aren't Maven modules. These are coming from the Ceylon SDK. There's one more thing I had to do here, which is that if you look at this module here, the Ceylon interrupt persistence module, oops, you didn't see that. it declares a dependency to hibernate to one API. Okay, that's where this module, the dependency, gets its JPA API from. Okay, this is from Maven. This is a Maven dependency. But over here in our module, we're actually getting the JPA API from here. Okay, so we need to declare in this overrides file that that we're going to remove the dependency to Hibernate's version of the JPA API that's coming from Maven, and we're going to get it from here. Okay, so we're messing with the dependencies of this module at the point where we're assembling our application. Okay, so that's how you can adjust the dependencies of things you depend upon when you assemble together a whole application and resolve conflicts between dependent modules. Oops. So that took it. So we touched, so we touched there on modularity in Ceylon, right? So, what are we getting from this module system? We're getting language level constructs for defining modules, expressing the dependencies. We've seen that with the module descriptor, controlling visibility between modules, so we can have private packages within a module that other modules can't see. We get versioning. You've seen that in this, in our module descriptor, we cleared the versions of things that we depended upon, and we can use the overrides file to adjust the versions of the things we depend upon. Okay, so hopefully that that what I showed you makes those ideas concrete. We get module archives and module repositories. Okay, so a module archive is what is the artifact that a Ceylon module will compile to. So if we look at our, in our program, what's generated when we compile our code is this car file. Okay, this car file is basically a standard Java jar with some extra Ceylon metadata. There are no .class files generated at any stage of compilation. Okay, it directly generates this module archive that Ceylon knows how to run. Now, obviously, this car file here that you're looking at isn't a standalone runnable program because it has dependencies upon other cars. You can see you can see over here, the other libraries that our app depends upon. For example, it depends upon Ceylon collection, which is in this other car file that's in a different module repository. Does it say which module repository that's in? No, not quite. But so the Ceylon compiler and the runtime and everything knows how to look up dependencies of the program in all the module repositories that are set up. So we get automatic fetching of dependencies from module repositories at compilation and runtime. We get module isolation at runtime. This is an important feature. This means that it is possible to have dependencies which are using different versions of something they depend upon at runtime. Okay, so you can have two different versions of the same module in your program at runtime. Okay, as long as the dependencies are not re-exported. Right? There's a problem, for example, that Jigsaw, which is coming soon, doesn't solve. All right, Jigsaw doesn't let you have two different versions of the same module in your program at the same time. We get interoperation with Maven and NPM, and finally, the interesting bit from our point of view from this talk is that we get assembly tools. Okay, what's an assembly process? An assembly process is a process of taking a bunch of individual modules, all the modules that form our program, right? A bunch of individual cars is what gets spit out immediately by the compiler, and assembling them into a single artifact. right, that I can run, right? Now, I don't need to assemble a program to be able to run my Ceylon program. I can use Ceylon run to run it. But if I want to run my Ceylon program with Java jar or whatever, Java minus jar, then I need to assemble a single fat jar. If I want to run my Ceylon program on a servlet engine, then I need to assemble a war. If I want to run it on Swarm, I need to assemble a Swarm fat jar. If I want to run it on Jigsaw, I need to assemble a Jigsaw mlib folder, etc. Okay, so assembly is an important phase of the notion of building a modular program in Ceylon. So to assemble with Wildfire Swarm, we have a plugin for the Ceylon command called Swarm, and its goal is to simply assemble a fat jar using a Wildfire Swarm fat jar for a given Ceylon module. So to use this plugin, you have to install it, you have to compile your Ceylon module, and then you have to swarm your Ceylon module, okay, which performs this assembly phase of aggregating together all the transitive dependencies of your module, together with a bunch of Wildflight APIs, and aggregating them into a single jar, which you can then run with Java minus jar. Now IntelliJ can do all this. Let me first show you that you can do it. Let me stop the demo, and then so when I run our demo app, you can see. Well, wait. Let me show you how I can run it the first time. The first time I run it, I simply open up the module descriptor and then I run the module using Swarm. Okay, so it's going to assemble. It's currently assembling the Swarm fat jar. This is a little slower than I would like, so we're going to have to wait for a few seconds. See, that Wildfire Swarm looks at the things you're using in your application, and then assembles together this list of Java EE APIs. And then it runs the fat jar. Our Java E environment starts up. You can see it's starting all the services, and including JPA, started, Hibernate, exports the database. There we go. All right, so we can. Using Insomnia, we can have a look at, oh, what the hell? Okay. So we can send some requests to our program and get some responses back in JSON form. So as I said, the process of assembling is a little bit slower than I would prefer, but it's what it is. Alternatively, we can assemble it for an application server. You can, and in this case, instead of using Ceylon Swarm, we use Ceylon war, which will assemble a standard Java EE war from our module, and then you can deploy it to Wildflower or whatever by throwing it in your application server deployed it. directory. That is obviously much faster to assemble, and it's fast, and it's equally as fast to start up. So it's good for testing, I guess. There is no code or metadata changes required in between running on Swarm and running on a regular application server. It's just a difference in the command you run to assemble the program. All right. So now let's have a look at what the actual code for our program looks like. So what have we got here? We've got a script for setting up for populating a database. We've got a standard persistence.xml, which configures Hibernate in this case. We've got the module descriptor we've already seen. We've got this JAX-RS thing called the application, which I only really need in order to set the root path of the REST application. Seems a bit crazy that I need a class for that. And then we get to the interesting stuff. So here's our model of our domain model, right? It's a class called employee. And it has an ID. You can guess that that's like the surrogate key in the database. It has a name and it has a year. It's an entity class. Entity is the JPA annotation at entity, right? Now annotations in Ceylon don't look like at capital entity, right? They just look like lowercase entity, right? So there's a mapping which happens from Java that presents Java annotations to a Ceylon code in a natural way. Generated value similarly is the JPA annotation so that this surrogate key is generated by some unspecified mechanism. ID says this is a primary key field. Late is an annotation which specifies to Ceylon that this field is going to be populated after instantiation of the object, okay? So this is interesting. This is a result of null safety, okay? Once you have null safety built into the application, you can't do what Java does and say, hey, I'm just going to, if you instantiate an object and you forget to initialize a field, I'm just going to initialize it to null, okay? Why can't you do that? Well, because null is not is not an instance of the type integer, okay? So the notion of having type-safe nulls in a program means that the compiler has to get all involved in validating the initialization logic of your code. Now, okay, there are some languages around at the moment which claim to have null safety because they have nullable types and non-null types, okay? But which don't do that validation of the initialization logic. And what that means is that their types lie. You know, they have a type integer which could actually contain null in it, right? So that's not really null safe, okay? But Ceylon isn't like that. Ceylon, if you declare a field of type integer and not maybe integer, then it really can't contain null. Right? So, problem with that is that, you know, we didn't really want to go and have to define this you know, in this case we have a generated value that's being generated by JPA when you persist the object. We didn't really want to have to say that this is maybe integer, it's an optional integer, and initialize it to null. We'd have to write, you know, equals null, right? And then all our other code would have to, well, I guess it's not using null ID anywhere. But then all other code, whichever uses ID, would have to handle the case of null, right? Even though, you know, we don't think it can ever really be null. So Ceylon has this late annotation. What late says is that, let's look at it. Let's ask it what it says. Annotation to disable definite initialization of an attribute. And what it says is that we're going to suppress the compiler error that would appear that says must be definitely specified by the initializer of the class. But you have the responsibility to initialize this before you use it, and if you happen to use it before it's generated, then there'll be a runtime exception. Okay, so it actually checks, all right? So it really, so if you try to access this field ID before you've explicitly initialized it somewhere, or before it's been generated by Hibernate in this case, then you'll get a runtime exception. Okay, so that's, it's a runtime exception. It's sort of a little bit like a null pointer exception, but with the difference that it's guaranteed to happen right the very first time you access this, not some other later time. All right, so that's important. This is, let me go. So this class is a class which interacts with JPA. It's a service class. It's like a data access object or something. So it injects an entity manager using inject, which is the javax.inject. Okay, this is the Java annotation. The entity manager gets injected. This is the entity manager from our interop package. It's a Ceylon entity manager. And you can see we're using this nice criteria API, which is completely type safe. You can see that we're using the type safe what's that? Oh. Get the key command. The key shortcut. This is a feature of Ceylon which enables you to have a type-safe reference to elements in your program. Just like, this is sort of like employee.class in Java, but you can see I can also reference attributes of the class, like employee.name. And that enables me to have this, this really type-safe criteria query API. Finally, our JAX-RS resource injects this employee service and has a couple of methods which you can see use the JAX-RS annotations. For example, here we have an operation which gets a list of employees, and you can either specify a name, an ID, or a maximum number of employees, and it does the right thing. The point about all this is you can see we're writing completely natural-looking Ceylon code. We're using all the Java annotations, and we didn't have to do anything weird. And that's all there is. That's all there is really to the app. It looks like I'm running out of I've run out of time. But what I was gonna mention finally is that one of the things that Java's missing is this type-safe meta model that we saw there. And so instead, JPA defines a meta model that is generated by an annotation processor. Okay, so you have these employee underscore classes which get generated. And that kind of works, but it's a pain, and the criteria API is overall pretty verbose and difficult to use. Because Ceylon has this type-safe meta model built in, we don't need that, and so I've designed recently a criteria API that follows the basic design of JPA's criteria API, but is much more type-safe and much more pleasant to use. Ultimately, the conclusion is that the resulting code is very clean and elegant. The package process of Swarm is a little slower than I would like, but it's tolerable. and you have the option of using Ceylon WAR, which is a little faster assembly when you're just testing. The EE mode that I talked about isn't just for Java EE, it works for all kinds of other Java reflection-based frameworks. This new criteria API is really nice. And you know, this is a simple demo app, but the technologies it's using, you know, offer a mountain of stuff to get your fingers, you know, really teeth into. This is a great platform for building microservices. You can get productive really quickly with this. And then Ceylon offers a lot more functionality you can grow into. Cool. Thank you.